Hey everybody, and welcome back. This is Mr. Corb with hashtag CorbStatChat. I know I've been away for a while, but we got a new semester coming up, and I'm ready for a great semester of learning some more statistics with you. So what we're going to do today is we're going to talk about something a little bit different, and we're going to talk about SOCS. Okay, obviously not those SOCS, but we're going to talk about something called SOCS, which stands for Shape, Outliers, Center, and Spread, which is a great way for us to represent data on a whole new level and describe data in a much more meaningful way. So we're going to learn about how we're going to look at a histogram, or we're going to look at a 7-leaf plot, and what we do is we take SOCS, S-O-C-S, and then describe it much better than just saying, oh, that's a cool graph. I mean, they're all cool, but what we have to do is describe it a little bit better, especially if you're taking AP statistics. This is the formula for to make sure that you get a very exceptional grade on the AP open-ended questions when they ask you to describe data. So follow along with me as we talk about SOCS. Okay, let's first start out with shape. Shape so the questions that you need to ask yourself, does the histogram or 7-leaf plot have a single central hump or several separated bumps or humps, whatever? Okay, these humps are called modes. Okay, so we have something called a uniform model, which has 0 mode, so no mode, nothing sticks out, nothing's crazy. Also called rectangular. We also have one mode where we have unimodal, where we have just like one hump in the middle, and then we have something else that's called 2 modes, which is bimodal, where we have 2 bumps. And those could be due to a bunch of different factors that we'll talk more about in this course. And then we have 3 or more modes, which is just called multimodal. Okay, so the next question to ask in shape is it symmetric? So can you fold it along a vertical line through the middle and have the edges match perfectly or pretty closely? Or are there values to one side versus the other? So if it is symmetrical, think of like our bell-shaped curve. Our bell-shaped curve is going to be definitely symmetrical, right? Because if we fold it over along that vertical line, vertical axis, we get one side that's going to be equivalent to the other. So we have data over here that's equivalent to data over here. So we can definitely figure out what our center is, which is going to be coming up here. But shape, is it symmetric? If it's not, then what we have something is called skewed. And we're going to be skewed left, skewed right. And the thing you look at to determine if it's skewed right or left is that there's usually thinner ends that are called tails on either side. And if the tail stretches out further than the other, the histogram is going to be skewed to the side of the longer tail. Meaning that if we have a bunch of high values up here or low values, and if we stretch those out, it's going to be a tail. What happens is that's pulling the rest of the data up. So we have this big, say that this is a unimodal model. So we have a unimodal model. So we have a unimode, one mode, but it trickles off to the right-hand side. That's actually pulling up your mean, pulling up your median, stretching out your standard deviation, and that's going to be called skewed. Okay, so that is shape. Okay, let's move on to outliers, which is the O in SOCS. So do any unusual features stick out? One representation of this that I like to use, one example of this that I like to use every time, is say that you are in a cul-de-sac. Okay, at the end of your cul-de-sac is this multi-million-dollar mansion, and all the other ones are priced around $150,000 to $200,000. Right, so you have a multi-million-dollar house, big old house with like 18 bazillion cars in there, and then you have all these other houses that are on the street. Now there are more little houses on the street, but what's going to happen to the mean of that street value? That street value is then going to be pulled up. And I'm going to be using this information when we go into talking about center, because there's a difference between using the mean and using the median. And one is going to be better than the other in certain situations. So outliers we're looking for either a really, really high value or a really, really low value. If the data is symmetric, okay, typically there's not going to be outliers. But if it's skewed, that's when we start looking for outliers. So if you have a skewed model, skewed right or skewed left, really look for those minimum and maximum values that fall. If you're able to calculate it, this is the best way. Fall 1.5 times the interquartile range from Q3 and Q1. So we subtract the interquartile range times 1.5 from the Q1, and then which is quartile 1 in a box and whisker plot, and then we add 1.5 times the interquartile range to the upper end of the box, which is Q3. If it falls outside of those, outside of the fence in a 5-number summary, then it's going to be an outlier. So that's how we actually mathematically calculate it out. But if you don't, you just have to look and try and figure out, okay, it's really skewed right. We have this one data value that's way, way, way up here. It's that mansion data value. If we remove that, we get a better representation of the whole street. And that's where we talk about 5% and 10% trimmed means from before. Okay, so those are outliers. So are there any gaps? Figure out where the gaps are, identify what potential outliers are, and make sure you identify those and write them. The next part of SOCS is going to be the C, which is center. If you had to pick a single number to represent the data as a whole, what would that number be? Would it be the mean? Would it be the median? There are different situations grant different things. So if it is a unimodal model, and it's symmetric right in the middle, so it's that nice bell-shaped curve, the mean and the median should be exactly the same if it's perfectly symmetrical. Okay? If it's perfectly symmetrical, it's going to be the same. If it's not, if it's skewed one way or the other, then your mean might be higher than your median, or your median might be lower than your mean, or vice versa. Okay, so you can have your mean and median as you start getting a skewed right or skewed left, mean and median start to drift apart from one another. And thinking about that mean versus median scenario of the mansion at the end of the street, okay, we have this mansion up here that's pulling all of those values up. Okay, it's pulling all those values up. The problem with that is that what's it going to affect more? Is it going to affect the median more, or is it going to affect the mean more? It's not really going to affect your median at all. Okay, you have one number that's really high, you have 100 other houses that are on the street, it's really not going to affect it. Okay, it might shift it up a little bit or down a little bit. Okay, but if you're going to definitely impact the mean severely, especially when you're talking about multi-million dollars, like say $5 million house versus $200,000 house. Okay, you take that number out, you take that outlier out, you get a much better representation of the whole street, and that's the 5% trimmed mean if we were going to do that. We're not here, so our median would be a much better representation of center than the mean. However, your mean is still going to be more accurate overall in general use purposes than your median, because it takes into account the sum total of all of the values, all of your data values. So just keep that in mind. Sometimes your center, if it's really, really skewed right, really, really skewed left by severe values that outliers are impacting this, you're gonna want to use the median as your center representation. So keep that in mind. So you can eyeball sort of where it is if you don't have any data values. So again, keep that in mind. Understand that mean and median are going to shift differently. Mean is going to be affected much more severely than median when it's skewed. End of story. And the last S is going to be spread. Okay? Now, up until probability and statistics, you've actually been doing spread, but you've only been doing spread by the use of finding the range of values. So the spread is just how wide is our data. Okay? So how far apart are each of the data values roughly? So before we have prob stats, what we have is this idea of range. So we have the high value minus the low value. How far apart are the two extreme values, the min and the max? That tells you how roughly wide the values are. But the problem is, question is, what is the problem with that? Oh, it tells me how wide the whole data is. Think about the house scenario. If we were to put it on a number line and we had this multi-million dollar house that was way up here, okay? The issue with that is that it is the whole way up there. If it is the whole way up there, then it's going to shift and greatly impact the range that doesn't really represent the range of the whole street. So if you tell somebody, oh, our houses on our street range from $100,000 to $5 million, okay, it doesn't really help get a general picture of what the average house looks like. And that's what we're trying to do here. Give an overall picture or description of the data. So what we have to do is then rely on something that we learned in stats, which is the standard deviation. Standard deviation. Okay, that was the song. Okay, so standard deviation is the average distance from the mean. Okay, the overall average distance from the mean. So if we look at our spread of data, which is using the standard deviations away, which we've calculated before, we've learned how to calculate it, we are looking at the average distance from the mean, which means that we are looking at our center value, how far away are all the numbers from all the center values. So we have plus and minus 1, 2, 3 standard deviations away. We've talked about Chebyshev's theorems before. We talked about the empirical rule and we talked about normal distributions. But just remember that spread is much more than just the range. It's also the standard deviation. And standard deviation, if you can calculate it or you have that value, then it's much more effective than using the range. Okay, so that is SOCS overall. So if we're looking at the shape of the data, so what kind of data is it? Is it symmetrical? Is it unimodal? Is it skewed right? Is it skewed left? So all those values play into the shape. So describe the shape of the data. The second thing is going to be our outliers. Are there any outliers? If you can calculate your upper and lower fence, then do it, because that gives you a guarantee of what the outliers are. Okay, if you can't, just looking for really high values or really low values, extremes that don't really represent the whole data. Okay, and then we have that was the S, the O, the C is going to be the center. That's either going to be the mean or it's going to be the median. So figure out which one's which and how they play into a large set of data versus a small set of data, or skewed data versus symmetrical data. Which one's better for which? And we do that in a whole another video, so we can talk about that then. And then lastly is going to be the spread of data. You start with the range, but then if you can, find the standard deviation and represent the spread as standard deviation of the entire data set. Thank you. This has been Mr. Korb. I will see you later with #KorbStatChat. Peace.